All right, we need to talk about torquing all of these items that we just went over. I think I just carried my pen into my office. So we got to talk about torque, which you've already talked about already, in and out, but we'll make it official. There we go. All right, bolt torque. Obviously, we need to use the right torque as aircraft mechanics. We can't just guess at it. I suppose if you're working on a car, you can. And I guess that's true because I used to work on cars and we didn't use torque wrenches. Hardly ever. All right, let's see. So we'll just throw out some obvious stuff here. We must use proper torque. And I say, this is me, do not use impact tools. Unless specifically allowed. Right, we have impact drivers, electric screwdrivers, all kinds of stuff. I will just say this is my take on that. Use them with caution. I don't like to use drill guns except for on a few things on my aircraft because you end up stripping out the screw heads and it makes it look like crap. And it's like, well, if you're that much of a hurry, maybe you ought to go find something else to do. So I don't. I did get a call from one of my FAA friends called me up and he said, hey, what are you teaching people about use of cordless screw guns? He said, I know everybody uses them. You know, do you tell them, what do you tell them? I said, I don't really tell them anything. He said, well, let me tell you why I'm asking. So recently, well, not recently, seems like it to me, but a couple of years ago, there was a very well-known flight instructor working on his own airplane preparing for an annual, and he was under the aircraft removing panels with a screw gun, which a lot of mechanics do. And this happened to be what's called a wet wing aircraft, which means that when they built the wing, then they seal the wing and then the fuel goes in there. There's no bladder or internal tank, which is very common. So he's got his gun and he's just on there in a creeper and he's undoing all the panels and he gets to a panel, he starts undoing all the screws, kind of drops down. Oh crap, that's a fuel panel. Starts to leak on him, so reverse the gun, put it on there, pulled the trigger, and that was the end of his life. The plane exploded, hangar, so that was local. And then this FAA guy said when he started looking into it, and I forget what number it was, but it was a shocking number of mechanics die annually from this exact thing. So, yeah.
Is it because when he goes back in, it sparks and ignites
Yep.
it? Oh, no.
Well, because it's a drill motor with exposed stuff, and it sparks when you use it. So apparently Snap-on makes an aviation version. I don't know if it's spark proof or what, but it was like some ungodly, $12,000. I'm not making that up. It was like a double digit kind of a thing. So I just really hate it when you're working on an airplane in a hangar and you hear people with their screw gun and they just do it until it hits tight and then the bit just bounces around, and like, okay, well, that was tight enough, and you're going around. Because we're going to stop and think about it. What we haven't talked about is the pricing. Have we talked about the pricing of aircraft around here? Yeah, like, just a basic crappy flyable 150 is $30,000. A decent 172 is going to be $100,000. A 182 is a used 182 that's in the 60s is going to be over 100. A new one is near $1 million. So, you got to use some finesse on these things. And mechanics, sometimes it irritates me. It's like if somebody pulled up in a Ferrari, you'd be like, "Oh my gosh, it's a Ferrari!" I'm like, yeah, that's cute. Kind of money that we throw at our airplanes makes a Ferrari seem like a bargain. Anyway, so yeah, that's my thing on that. So let's be careful with that. Torque is based on the bolt diameter, E-I-A-M-E-T-E, diameter, not the wrench size. not the wrench size. We have several A, B, C, D, E, C. So to achieve the proper torque, we use a torque wrench. A torque wrench. There are several different types of torque wrenches. We have the click type. I like the click type. Click type. I had a student one time strip out an entire row of bolts. Ruined them all. What the hell did you do? I had a click type. I said, well, she goes, well, it didn't click. I said, what do you mean it didn't click? And so I went up and I grabbed it, and I can click this one with my fingers right now. I'm like, well, it clicks just fine. She goes, huh? Oh, I thought it would go like click, 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 and make like some clicky noise. I'm like, it doesn't have batteries. It doesn't. So. But anyway, when you achieve a proper torque, it just clicks over. You just feel that break away. And it clicks once, and then you stop. So this has a knurled handle on it. That's called knurling, where it's all bumpy. And you need to hold it on the knurling. Every torque wrench is going to have a spot where you're supposed to hold it. You can't hold it over here, make up stuff like that. You got to hold it where it says, because it's based on a certain amount of pounds at a certain distance. That's the term inch pounds, foot pounds. It's how many inches or pounds. So click type, I love click type. I think they're my favorite. Should be my second favorite now. And the reason why is because you don't have to get your eyeballs. You can set it for what you want, and then proper torque, and then you're done. The drawback to that is there are some applications where it says put 20 foot-pounds of torque on it and hold for 3 minutes or 15 seconds. And you're like, well, you can't. This is probably the crappiest torque wrench I've ever seen because it's only that long, and it goes up to, what the hell is this one? Pounds, inch pounds, up to 300 inch pounds. It's a lot of weight for a little tiny torque wrench, but it has a dial on it, and this section moves, so you have to make sure it's on 0 when you start, or calibrate it, which we'll get into that. But anyway, so you have the dial type. I don't like the dial type because you have to get in there and watch it, what you're doing, and if it's not in a spot where you can get your face in there and watch it, then it makes it difficult. And I don't like this one because the handle's too short. There's the beam type, which is old-timey. These are actually really cool, I think, for teaching people because it's got a pivot. And the idea is you have to hold it in such a way that this handle does not interfere or touch the rod, so you have to hold it just perfect because the way you hold it has a big determination on the final torque. Like, for example, you go back to this one that's just a little one, not a lot of torque. I could twist my wrist and bring the torque up without ever pulling. So if you're twisting your wrist and pulling at the same time, it'll actually put stress on that and cause it to click sooner than it should have been. So you want to take it and you want to do a nice, even, steady pull at all times, and be careful not to twist your wrist when you do it. So, all right, so you have the click type, you have the dial type. I like the click is good because it's easier. Dial is good because you can actually get in case you have to hold the torque for a period of time. We have the bar type. And when I got into aviation, they didn't exist, and they were super expensive, but the electronic.
It's like $800 or so.
Yeah, well, it was like $8,000 when I got into business. So, and it was like, what? Electronic? You got to be kidding me. They make that now? So there's your click type. It has a scale on it that you pull back the lock and rotate this until you get the numbers that you want. I don't have time to go over it right this minute. Dial type, bar type, and then let's see. Oh, yeah, bar type's kind of cool because the way it works is you pull this, one bar bends, one bar stays straight, and it shows you what you're achieving for the force. And the electronic type. I actually own this one down here. My father-in-law gave it to me. Somebody gave it to him, and he's like, I'm never going to use it. And so I brought it in and I tested it. This thing is like $20 to see how accurate it was. It was so unbelievably accurate. I was shocked. So Snap-on torque wrenches come in a red box. This one, is this Snap-on? Yeah, Snap-on. It says precise, 1% accuracy. See user manual for complete accuracy statement. Little asterisk there. So because I was building engines, I wanted the best torque wrench money could buy. And I bought two Snap-on torque wrenches. They did not come in red boxes. They came in gold boxes. And it was the biggest piece of crap I'd ever bought because I used to calibrate torque wrenches. And so first thing I did is, went over and checked it. I'm like, this thing is freaking, it was all over the place. It was crap. So I had to send it back to Snap-on, came back. Went from unbelievably crappy to more believably crappy. So I had to send it back again, and then they finally got it right. So I don't know. I don't have any super love for Snap-on or that. Having calibrated torque wrenches, because everybody always asks, what do you like? So that's my story about Snap-on. I've calibrated torque wrenches in our shop. We did it for all kinds of places, and they're all the same. I don't care. Harbor Freight, whatever. The only ones I don't like is the one I bought from Sears, because the handle has a little tiny window, and if the handle slips, the window turns, and that I didn't like. But it was accurate as hell when it was working. So anyway, we got those. The idea of torque. I'm not going to write all this down, but let me explain it to you. The idea of torque is that you are putting a certain amount of twist on a nut or bolt, and that twist is in inch pounds or foot pounds. So if it was 1 foot-pound, it's literally 1 pound on a bar that is 1 foot out. You're putting 1 pound. That's 1 foot-pound. 100 inch pounds be either 100 pounds at 1 inch or one. Let's see. I forgot what I said. Anyway, or that many pounds and that many inches, whatever the hell I was trying to say. All right, but the idea is, so engineers figure out how tight something should be. And how tight something should be is going to depend upon its application. So for example, I don't have my cylinder anymore. We have that cylinder, and that cylinder is bolted to an engine, and inside of there is a piston. And so the piston goes up, and the fuel-air mixture ignites, and that pushes the piston back. Well, while it's pushing the piston this way, it's trying to push that whole cylinder assembly that way. And it's trying to depart the crankcase. So we have a crankcase and a cylinder bolted on. Everybody with me so far on that one? Okay. So what happens is we need to preload those, and it's held on with a stud, which I told before is set into the crankcase. The cylinder goes on, then a nut goes on that. And what happens is the engineer has to figure out if this is trying to leave with this much force, we have to tighten this nut so much that it takes that stud and actually puts it under a tension that exceeds what the cylinder is trying to leave with. So if the cylinder, I can't remember the number, something like 11,000 psi. If it's trying to leave with 11,000 psi, we got to have more than 11,000 psi stretching on that bolt, even when it's not running. If you have less than that, every time that the piston fires, that cylinder tries to leave, it does a little bit. And every time it does a little bit, it stretches that stud and it goes back to normal. And it'll do that a couple of 100 times until it breaks. So you have to preload it more than what the cylinder's trying to leave with. Like, it sounds like you're working on cars. We do the same thing with heads. You put a head on a car, those bolts have to be tighter than the force trying to make that head come up. Well, in the perfect world, what you want to do is figure out that amount of tension that you put on the bolt with a stretch. You're stretching it. And so in a perfect world, we would actually take a micrometer and we would put it on that and we would measure how far we stretched it from when we started to when we finished. But you can't get a micrometer on head bolts and everything. It just doesn't work. It's not practical. So an engineer sat down and figured out, if we put this much twist on it, that equals that much stretch. So this is it's a poor way of doing it. It's a thoughtful way of getting stretch. So this is a compromise. What engineers really want is how much stretch we put on a bolt. The compromise is we'll twist it with a nut, and based on mathematical calculations, that will equal a certain pull. Now on high horsepower engines, Lycoming does actually use stretch bolts that are machined on both ends, and you do torque them to an action with a torque micrometer. It's a between the two, but you actually do use a micrometer and you get them to a certain stretch. So that proves my point.
How do they do that then? When they're building the engine, if they've got the studs and
Oh, it's actually a connecting rod bolts.
Oh, for connecting rod bolts?
Con rod bolts, yeah.
Oh, okay.
Okay. So I tell you that to tell you the engineer sat down and he figured out if you put this much pull on it, it will equal that much stretch. Got it? Except it has to be under exact circumstances. Well, what happens if we're all doing it and you on yours, you decide you're going to use thread locker, you're going to do yours dry, you dropped yours in the dirt, and I'm going to use oil. Use thread locker, who knows what that does. When you use your dry, so you're going to be less torque than me. You dropped yours in the dirt and didn't have a couple pieces of sand in it, so your torque is like 1/2 of mine. And I used oil and mine went 40% more than his. So that's why that chart says the threads must be clean, oil-free cadmium threads, because that's how the engineer figured it out. Now, not everything in aviation is that way. Engines specifically are wet torque. They must have oil. And it doesn't just say add oil. Lycoming gives you a couple of 3 choices. One of the ones I use is, it's a very specific. It's like 80% STP oil treatment, which is hard to find, and 20% STP, and 80% SAE 100 weight oil. That's very specific what they want. And if you fail to do that, then you fail to achieve the proper stretch, and you will have problems. One day I used to keep an airplane here on the airport, and the guy saw me, checking out my airplane, and he just wanted to talk. He's like, "Let me ask you something. You ever work on airplane engines?" And of course, I said no. But what's your question? And he said, "Well, all of my studs that hold the cylinders off, it's like after every flight, it's like when I open the cowling, I'm missing 1 or 2.
Oh my God.
And so I'm constantly having to go in and have these studs replaced." I'm like, "Well, who built your engine?" "Oh, I had it done at an AMTP school, like in the Midwest." I'm like, "Well, okay, well, you're getting what you paid for, aren't you?" So what was happening was they dry torqued that engine. It was supposed to be wet torque. And the studs did not have the proper preload. And so while he's running it, it's constantly stretching the bolts until they fail and fall into the cowling. So eventually the cylinder will leave and you get a cylinder depart light. So it's important, I'd say that, to say why do we twist? And the twist is not the twist, it's really the pull that we're after, but the torque wrench is how we achieve that. So hopefully that made sense, because it's very important. So all right, torque wrenches must be calibrated. Must be calibrated because it's a return to service number. If something says you must torque it to 100 inch-pounds, well, how do we know it was 100 inch-pounds? You've got to have it calibrated. How do we know it's calibrated? It's got a sticker on it. What if it doesn't have a calibration? Well, you got to go get it calibrated. So the general rule of thumb is annually, when dropped, or as per repair station manual. In our lab, we actually have the exact machine that I used in my engine shop. And we were using that machine to calibrate outside stuff. After I left, at some point the FAA came in and said, "Hey, we really don't want you, this shop, doing outside calibration work using that machine." And so they just took it off and they put it in the storage unit. And I said, "Hey, where's the old torque wrench machine?" They're like, "Oh yeah, we just storage." And I said, "Well, can I have it?" And they said, "Take it." So I bolted over here. But that machine, and it's really cool, you can calibrate it. I've calibrated weights to calibrate it. But I had it, I would build an engine here, and it was sitting like right there. And so every time I changed the setting on my torque wrench, every single time I changed the setting when building an engine, I would just go over there and just do it. Just verify that my torque wrench matched the machine. And then I would torque the engine. And then I would change my torque. And I would walk over here. So how often did I calibrate my torque wrench? About every 2 minutes. So made for, why not? Sitting right there. What the heck? Made for a nice thing. Nobody could ever come back and go, oh my God, your torque wrench is so out of calibration. We have to recall your engines. I'm like, no, it's fine. Okay. So, but we'll be using that. You'll get a chance to experiment. Proper procedure is necessary for proper torque. All right, so we're going to hold the wrench properly. Hold wrench properly. This over here. All right. So if I have to torque this, obviously I can't just walk up to a bolt and push down like that. It's going to twist everything all to pieces. You got to make sure that you're holding properly without adding torque to something. All right, so if I hold it right, you'll be shocked. I'm gonna let you guys use, this is a cylinder-based wrench, by the way, and it just goes straight, so there's no change in torque. But if you hold it right here, you can either add or subtract torque an unbelievable amount just holding it here. So you have to hold it properly. If you have an extension on something, a straight extension, you just can't walk up and twist it. You gotta support the extension in a way that doesn't change torque. So you gotta think that through. So you got to hold it properly. Also, holding it properly means that you hold it where it's designed to be held. Right here on the knurling. This one is really difficult because it's got this little tiny handle. Well, I can't grab it like that because its effective length is right here between these two knurls. That's where it's designed to be. So I'm going to try and grab it right in there as best I can. I may have to use 2 fingers or whatever I will, but I'm going to try and hold it like that, so that I'm actually getting it in the right spot. Can't hold it like that. So, got to hold it where it's designed. That's why I say this one sucks.
How do you ever get that to 300?
I don't know. That's why I keep saying I hate it. I would never own that.
I thought those got sold with the handle too.
Huh?
Didn't it come as a kit with the handle?
It can't. If you add an extension to this, because this is like X number of pounds at X number of inches, it's reading it assuming you're pulling here. If I put a cheater bar and pull out here, it's just going to multiply it exponentially. So no, there's no handle. This is the handle. Can't add cheater bars. Hold properly. Apply steady, steady, even pressure. If you're jerking on it, you'll get a click type to click real easy if you jerk on it fast enough without much torque at all. So yeah, so even pressure, do not jerk it. Also, there's a thing about starting and stopping torque. So if you like using the ratchet mechanism, and you're going ratcheting, you stop and then it takes more torque to restart. So you could get in a situation where you stop, you come back up with the ratchet, and it clicks instantly. So it's best if you start and just continue all the way around until it torques. I mean, if you want to get really nitpicky about it, that's the way you need to do it. Use correct chart. Use the correct chart. All right, some of this stuff is like, yeah, you probably figure it out, common sense on your own. This is not a common sense on your own thing for sure. If I want to torque something, I have to know where to get the proper torque, and there's a hierarchy of what you want to do. So first is the manufacturer's specific torque. S-P-E-C-I-F. Specific torque prevails. Means it's the highest one. So in other words, I'm working on my Cessna, and I want to put torque something on the engine. I'm not going to use the Cessna manual. I'm going to use the engine manufacturer's manual and how they want me to torque it, which, by the way, is going to tell me that I should use a specific wet torque on the engine. Well, what if I'm torquing something on the engine and it doesn't tell me what to torque on the engine? Well, let's just say I'm putting the carburetor on and it doesn't tell me what the carburetor bolts are. Now what do I do? Nope. But thank you for stepping into my trap. So there, when I say specific, I mean it is the specific item. Like it will say the connecting rod bolt is, the cylinder base stud is, the nuts to the carburetor are. When it calls it out by name, that is the first thing we're going to look for. Or maybe I'm working on the airplane. It says the wing strut bolts are torqued to, right? That is the very specific item, and it will call it out. So first you're going to look for that. If you're working on the airframe, you're going to use the airframe manual. Working on the engine, you're going to use the engine manual. And by the way, engine manuals, they are very complicated, and a lot of information is not in the manual. They push it into side manuals that you have to know about. Well, how do you know about these manuals? You just have to know. All right, then we have the manufacturer's general. So then manufacturer's general. General torque. So in other words, I'm back to working on the engine, and I'm putting the carburetor on, and I've looked through the whole list of things that Continental has to torque, and they mentioned the conrod bolts and the crank gear bolts and the the cylinder base studs and the magneto, and it's like I read the whole thing, nothing about the carburetor, but I know the carburetor 5/16 nuts. Then I go to the engine manufacturer, is going to have a chart that looks similar to the 4313. Just says, all right, well, if we didn't say otherwise, then use 5/16. Or I'm torquing those wing bolts onto my airplane, and it doesn't say wing bolts. And I go, well, it doesn't give me a specific for the wing bolt, but they'll give me a general. Say all 3/4 inch bolts should be this. I'm like, well, it's 3/4 inch bolts. I'll torque it to that. Follow? So specific, called by name, then general. Okay, now if it's not in the specific and it's not in the general, 99% of the time you screwed up, because it is. The only time that AC 4313 really comes into play anymore is if you have an antique aircraft. Something that was like a Cessna 140, a Luscombe is a perfect example. They're very small maintenance manuals, right?
Yeah, it's hella small.
Yeah, it's half of it's like how to assemble it. It's like and you're like, well, I'm not assembling it, and so in your case, in that case, when you're working on older certificated aircraft, then you often get into 4313 because they don't give you a general. They'll just, and sometimes they'll even get the torque in the middle of the wording. Yeah, then you're going to do this and then torque it to this. Like, it's not even a chart. You just, it's a paragraph. And so you'll do that. But in these older planes, then and only then would you move to 4313. So that is a last resort. So last resort is AC 4313. So we don't start there, we end there. And remember, like engines are wet torque, airframes are dry torque. Things are all different. You really got to pay attention to what you're doing. So we have dry versus wet torque. We covered that, unless otherwise specified in 4313 at least, and that 4313, by the way, the chart in 4313, if I opened up the general torque chart in my Cessna manual, I would see no difference. The numbers are going to be the same. So it's really the same chart. That's why I said you'll never need 4313, because they put the chart pretty much in the Cessna manual or Piper Beechcraft manual. So unless otherwise specified, torque, or I should say torque values, torque values are for what kind of threads?
Fine thread.
Clean,
Oh, clean and dry.
dry, And clean dry threads. A wet torque will increase torque by about, depends on what you're using, 40%. That's a lot.
So is that saying that the bolt is stretching 40% more than usually would if it was dry torque?
I'm going to say no to that. This is my opinion. I don't know for sure, but it's the amount of foot-pounds you're putting on.
Okay.
It would be 40% more. What that relates to in stretch, I don't know exactly. And if it is a wet torque, you use the exact specified stuff. Not, well, I think this works better than that. Unless you want to go to engineering school. I mean, maybe some of you have, then. All right. Wrench size is not the bolt size. I'm not going to write that down again. All right, and last part about torque is using adapters. Using adapters. Let me see, do I have any pictures that I should be showing here? We got that, we talked about. Did I mention that the wrench size is not the bolt size? All right, sometimes we have to use torque adapters or adapters to get into stuff. I've had to make crazy little adapter kits where I had to put a socket on something, and then that socket had to have a wrench, and then that would translate into a wrench that I'd have to use and something like that, or something like this. So as I said before, everything on a torque wrench is based upon the distance from here to here. And if I do this, and I did something to 100 inch-pounds, I am going to substantially increase the torque by doing that, because it was based upon here to here, and now it's here to here. Follow? But if I did it to here, that would substantially reduce the amount of torque, because it was supposed to be from here to here, but really it's there to there now. Because you're still putting the same amount of torque on this spot, you're just either subtracting it or multiplying it. That's a bad thing. So to counteract that, you can often go sideways, which is close, but in reality, you have to figure the hypotenuse between here and here. So you got to be careful with that if it gets out too far. I'm hoping I wouldn't say hypotenuse, huh? So we have to figure out what's going to happen if we add an adapter to it, either that way or this way. And there's a formula for that. And the formula is not very difficult. And I will never, ever ask you to commit a formula like this to memory. But I will ask you to make sure that you know how to use this formula. And it is one of your projects, and it is on the test tomorrow. So what this is saying is we have this formula right there, which is T times L divided by L plus E equals Y. And what we have is T, right here, is, I'm going to make sure I get this right, T is the applied torque. So we have an adapter, and can you see the adapter right there? Their particular adapter is only, I think, 1.5 inches. Yeah, 1.5 inches. You see that? So we take this formula and let's look at what everything is. So T right here is how much to torque to. That's what we need to torque something to. So the book says I need to go to 135 inch-pounds. You see where I got that? It's just their examples at 135. It's whatever it is. It's whatever you're supposed to torque this item to is the T. And in this case, it's 135. And we have to multiply that times L. Well, what is L? L is 10 inches. That is the torque wrench. That is whatever it is from this point to this point. Or in this particular one, it would be this point to this point right here. And this one actually says it's 8 inches. So this is 8 inches. If I'm using this one right here, it's whatever it is from here. It's hard to do with these because it's like, pick the middle. So it's right there. So that is your L. In this case, L is 10 inches. 10 inches. And then we divide that by L, again, which hasn't changed, 10 inches plus whatever our adapter is. If we look at it, we're just adding the whole length. So what is our length? Well, it's 10 plus 1.5 inches. And I got that from right here. E is 1.5 inches. It shows it down there. And then I do the math. Well, the way we do the math on this is we do the top of the line and the bottom. So it's 135 times 10. We can use our calculator, which would be 1350, divided by 10 plus 1.5. It ends up being 11.5. And so we do the math on that. 1350 divided by 1.5 equals, oh, it's right in front of me anyway, 117.39. What does that number mean?
117.39 inch pounds of torque. That's what you need to set your torque wrench to.
That's what I need to set my torque wrench to. So I set my torque wrench to, here I got this one. All right, I'm going to set this and I'm going to go to 117.39. And then what does that mean?
It means that's what it's needed to achieve 135.
Then what am I going to end up torquing out to here?
135.
135. When everybody get that, because last class I had so many people, you do this and you literally are going to come up to my torque wrench machine like, okay, what are you going to do? Like, okay, I'm going to torque it to 179 inch-pounds. And what am I going to see? 179 inch-pounds. No. So if this says 179, this is not 117, sorry, 117, right? In their example, I've got wrong sizes here, obviously, but if I go to 117 here, out here I'm going to see 135. Is that right? Yes, 135. Everybody follow me on that one? Okay. You picking up what I'm laying down?
Actually,
Yes.
So that 135 is the length of the wrench and the adapter you're using?
No, 135 is
Oh,
what
that's
the
a torque.
book told me to torque it to.
Gotcha.
All right. And then what if we have to go backwards? It's the exact same formula. It's 135 times the torque wrench divided by the length of the torque wrench. Well, in this case, the length of the torque wrench is 10 minus 1.5, which is 1350 divided by 8.5, which is going to equal 158. So if I put 158 inch-pounds on my wrench, what does the bolt end up getting? Only 135. Only 135. Let's do one more. Let's just say, we'll do this. I've never done this before. Let's see how we have a 12-inch torque wrench with a 4-inch extension, not extension straight out, but, and we want to do a 3/8 inch fine thread to max torque. What will the torque wrench say? Now, of course, I've changed it so you don't have the formula.
You're extending it, or you're
We're extending it out. We're going this way. Everybody got that information? So it's T times L divided by L plus E is my formula because I'm going straight out. What is my T? Torque. T for torque. T for torque. Anybody, can you see that okay? What is my T for torque? What do I hear? 390. And I got that right here, 390. That's the max torque for a 3/8 inch bolt. Now I didn't specify fine or coarse, so I'll go with fine, times L. What is my L? 12 inches. That's the length of my torque wrench is 12 inches. And so I'm going to divide that by my torque wrench, which is 12, plus my extension, which is 4. So I get, I don't know, 390 times 12 equals 4680 divided by 16. So 292.5. I am going to torque that bolt until my torque wrench says what? 292, and the bolt is going to get how much torque on it? 390. All right. That's on a test tomorrow. Make sure you got it.
What is the What does the E represent? What is that?
E is the E extension.
Extension.
Now, as I mentioned before, now that you know that, something like this, there's no math needed because this is in line with this. It just goes way up, over, and back down. So this is perfectly in line to get around something. So there's no math needed. It's just you can really screw up by hanging onto it here. You'll get a chance to play with that just to see what it's like. No big deal if you screw up. All right, everybody got that for torque? All right, so I think we got torque. We got that covered. Wrench size is not the what? Bolt size. Okay. So that just leaves, I need to go over safety wire, which is kind of fun to do. Not a lot that I can really write about safety wire. I'm just going to give you some rules. And then when we're in lab, I will be happy to do demonstrations on how to torque. Because some things you just have to see and then you have to do. So we're missing a page here. Hang on. Where page did that one go? Oh, it's over here. Safety wire. All right. And again, that torque formula, you don't need to commit that to memory, but you do not have to use it. Do not have to use it. All right, safety wire. Safety wire. There's a lot of different safety wire material. You have to make sure you're first using the right material. One is stainless steel. Stainless steel is your go-to. That is your most common and used for safety of nuts, bolts. I don't really know how you safety a nut, but and other hardware that is removed for maintenance. Then we have copper, brass, or aluminum. And this is only used on emergency equipment. Only used on emergency equipment. Where the wire must be broken. Where wire must be broken to use. It would be a crying shame if somebody decided that the best way to safety this pin onto this fire extinguisher would be some nice 032 stainless steel safety wire, nicely twisted and put on there. Because in order to use a fire extinguisher, I'd have to go find a what? Wire cutters. What, do you got a pair of wire cutters? By the way, if you're ever house sitting somebody, it's always funny to just text them and go, hey, if you get this message, could you tell me if you have a fire extinguisher? But if you don't get it in the next couple minutes, don't worry about it. So, all right, so if it's safety equipment, a switch, egress slide, something like that has to be broken by hand in order to use, and we're going to use what? Copper, brass, aluminum, and I also don't think we'd want to twist it. We want to be able to break it. But otherwise, we're going to use what kind of material? Stainless steel. All right, so wire size. We're pretty much just going to talk about the stainless steel. So safety wire sizes. Safety wire sizes. I'm just going to give you some of the three most common. And the first one is 0.020 safety wire. And that is, and I'm going to get this right out of 4313, so don't yell at me if it doesn't make sense. Used on items with a hole diameter of .045 to .062 with spacing less than 2 inches. 2 inches apart. So in other words, I will paraphrase, in other words, small screws that are close together. That's really what that means. Then the next one we have is .032. This is your most common go-to safety wire. So most common, if you don't know what to use, most time you just pick up 032. So that's the most common. That's me. 4313 notes that it is used on items with a hole diameter larger than .045. So let me ask you something. If I have a hole diameter of .06, which one would I use?
020.
I completely disagree. Right there it says hole diameter larger than .045. Clearly .06 is larger, so you must use this one. But you're thinking, wait a minute. It fit that.
So then,
Well, what's around it?
I'm just telling you what 4313 said.
If the spacing is big enough.
I think it's the dumbest thing in there. It's like, wait a minute.
so what would you do in reality? Would you just go for the 032 because it's a bigger wire?
Oh, in reality, if it were small screws, a bunch of small screws that were 2 inches apart or less, I would use 020. If it's anything else, I'm going to use 032.
Okay.
That's just me. And then I know it'll be fine. All right, and then outside of 032, the largest that we usually use is .040, and they also make .041. So, and that is typically used on props or large bolts. So typically used on prop bolts or large bolts. Honestly, I added the large bolts. I'm like, might as well. Only reason why I've got 040 in my toolbox is for props. And there are some instructions, if you really read some of the Hartzell and Macaulay manuals, it'll tell you can use 032 in certain places. But it's one of those things where it's become such the norm, I use that word intentionally, that if you don't use 040, somebody's going to call you an idiot. So there's a lot of things in life where it's just easier to go the extra step and do the norm than to actually do it. If it says you can use 032, you can also use the bigger. But if I knew I could use 032, but I can also use 040 easily enough, I'm just going to use the 040 just so I don't have to hear about people questioning what I'm doing. So, all right, so how-to safety wire. I'm going to give you some written rules, and then we're just going to go with that. So, do you guys want a break? Well, what if one person has to poo and they're not fessing up? So now I got to give you a break. So I'll give you a couple minutes for that shy guy.